All right, yesterday we left off looking at solving a triangle, and we were discussing yesterday in length the law of cosines. And we realized that the law of cosines is wonderful because the law of cosines works in any situation. That is the beauty of the law of cosines. The drawback is the formula is a little bit longer. But the law of cosines becomes our only option when I do not know an angle with the side across from it. The law of sines becomes our only option when I do not know an angle with the side opposite it. So, looking at this situation, we want to solve triangle ABC here. All right, and what am I given? Well, little a is 8, little b is 12, and little c is 10. So, as I'm looking at what information I am given, what situation have I been exposed to here? Side, side, side. Absolutely. This is a side, side, side situation. The only option that we have is to start out with the law of cosines. Now, we need to make sure that we do this in a very specific order. And the reason that we need to do this in a very specific order is because, remember, that supplements have the same sign. Supplements have the same sign, so we need to be very careful to make sure that we find our angles in the correct order so that we can tell the difference between which angle I want. Do I want the one that is given to me, or do I want its supplement? So if we do it in the correct order, we won't have to consider that. Doing this in the correct order means that, first of all, I need to find the largest angle. And I'm going to use the law of cosines to find that largest angle. Now, in this case, which angle in this triangle is going to be my largest angle? Angle B, it's across from the biggest side. Okay, now, we should know that if I want to find angle B, that when I'm writing the law of cosines, that means that I'm going to have the cosine of angle B out in the back. Well, if I want the cosine of angle B out here in the back, that means I'm going to have little b squared equal to my other two sides squared, so a squared plus c squared minus 2 times my other two sides of a times c. All right, so we have little b squared, well, little b is 12 squared, is equal to little a squared, so that's 8 squared, plus little c squared, which is 10 squared, minus 2 times my a of 8, times my cosine, times my c of 10, times the cosine of angle B, which I do not know. All right, very quickly working together here, what's 12 squared? 144 is equal to 8 squared. 64 plus 10 squared? 100. Subtract. All right, what's 2 times 8? 16 times 10 is 160 cosine of angle B. Now I've got a comment. What do I do next? Does someone have a suggestion on what we're going to do next from this point? Where will I take it from here? All right, I need to get cosine of B by itself. Now, is there anything that I can put together? 144 is obviously by itself equal to, what about that right-hand side? Can I simplify anything there? Okay, so I have 64 plus 100. What is 64 plus 100? 164. Do I subtract 160 from that? No, that 160 is attached to that cosine of B. I cannot combine those like terms. So 64 together with 100 is 164. Subtract 160 cosine of angle B. All right, Katie, you got any thoughts on what we're going to do to start getting angle B by itself? I like that plan very much. We're going to subtract 164 from both sides. So 144 take away 164 is going to be negative 20 is equal to, those cancel, negative 160 cosine of angle B. All right, Alex V, what are we thinking now? Beautiful. We're going to divide both sides by negative 160 to get the cosine of angle B. All right, does somebody have that? Yeah, 0.125, really that's 1/8, right? Right? So if I think about the decimal 0.125, thank you, Daria, that's 1/8. Now, is that my angle B? No, that is the cosine of my angle B. That's what I would get if I did adjacent side over hypotenuse. If I want to find the angle, I need to do the inverse cosine. Absolutely, I need to apply the inverse cosine on both sides. So the measure of angle B is approximately how much? 82.82? All right. So angle B is about 82.82 degrees. Okay, now, the next thing I'm going to do is I'm going to set up the law of sines. Because now I have an angle in the side opposite. Now I have an angle in the side opposite, so I can go and set up the law of sines. Okay, now using that law of sines, I'm going to have the sine of angle A, which I don't know, over little a, which is 8, equal to the sine of angle B, which is 82.82, over little b, which is 12, is equal to the sine of angle C over little c, which is 10. All right, things are looking good. I know one full fraction. Now, at this point, it doesn't make a difference what I find next. All right, what do you want to find next? Let's find A. All right, so the sine of angle A over 8 is equal to the sine of 82.82 over 12. All right, we know enough about the law of sines to realize that I'm going to cross multiply. So 12 times the sine of angle A is equal to 8 multiplied by the sine of 82.82. All right, Samantha B, what am I going to do to start getting to angle A? Yep, absolutely. We're going to divide both sides by 12. So we have the sine of angle A equal to. All right, so we're going to take 8, multiply it by the sine of 82.82, and divide it all by 12. Zach, do you have that? 0.66. What is it? 1.4? All right, now that is not angle A, that is a sine of A. If I did opposite over hypotenuse from A, I would get 0.6614. So to find angle A, I need to inverse sine. So measure of angle A is going to be approximately how much? 41.41 degrees. Okay, so angle A is about 41.41 degrees. And how do I finish this up? You bet, you bet. Absolutely, we're going to find the third angle. We're going to find that third angle, which in this case, in all cases, means that the angles need to add up to 180. So my third angle is going to be angle C. So the measure of angle C is going to be equal to 180, subtract the 82.82, and then subtract the 41.41. So the measure of angle C is about how much? 55.77 degrees. So angle C, I can come back up here, is about 55.77 degrees. Any questions with that? Any questions with that? Okay.